Hello and welcome to this, the sixth in my series of videos on absurdities in science and technology. In this particular video I will be highlighting some of the nonsense I see in the concept of so-called big data. What with video and audio streams, social media, purchasing data, news feeds, as well as the usual textual data and much more. The jumble of computer-stored data has become so large, so complex, and so non-homogeneous that we can no longer talk of data sets. This is because we are unable to construct data categories that are consistent across the various formats. How can the data in a video clip be categorized without some human filtering? Furthermore, standard database technology is not coping with the 4 V's: exploding volumes of data, increased variety, the huge range of data types, sources and sinks, and increasing velocity, the speed data is captured, processed and transferred, or the veracity, checking if all the data is correct. A major issue in all data analysis is how to separate the signal from the surrounding noise. Big data is a recognition that the noise to information ratio in the increasingly massive agglomeration of computer files has become uncontrollable. That is, until the advent of big data. For despite all this noise, big data is being sold as a solution. Because, after all, once we identify a problem, given enough resources, we can always solve it, right? No, we couldn't be more wrong. Take the example of sophisticated mathematical equations, which are used to describe a vast range of scientific observations. It's one thing to represent each problem as a series of equations. It's quite another to solve them analytically. We must ask, just how well does this abstract construction called mathematics actually function when solving equations? Not nearly as well as most people think. In the 1960s, Roger Franks showed the difficulties in solving the various types of equation. He constructed 2 3x3 tables. The one on the left concerns linear equations and on the right nonlinear. Apart from linear algebraic and ordinary differential equations, everything is either very difficult or impossible to solve by analytical methods. The more equations that are needed to model any particular problem, the more difficult those equations are to solve. Enter the number crunching computer as a way out of this analytical dead end. Although now the devil will just reappear elsewhere in the detail of big data. What if computers too solve far less than was originally hoped? The butterfly effect always haunts the process. Will different choices and resolutions of the data lead to different solutions? Now, earlier videos in this series have shown that no matter how elaborate or sophisticated or particularly subtle a scientific description may be, it always comes with paradoxes. These paradoxes are an unavoidable consequence of observation, and so must interfere with the sampling of data. Consequently, I am asking whether, because of such paradoxes, computation too has reached the equivalent point of diminishing returns. Are we now at that position where we can't even handle large amounts of coherent data, let alone the mountains of the incoherent stuff? Not according to the people selling the tools of big data. They say that big data is the action of examining large and varied data sets with the aim of uncovering hidden patterns. They claim to be able to identify market trends and customer preferences and to predict behavior, which will help businesses make better informed decisions. Basically, the aim is to focus down on previously unseen correlations in the data. Correlations. Those of you who have seen the other videos in this series will know that I have discussed major paradoxical problems with the concept of causality in our nonlinear world. Correlation takes that uncertainty to a whole new level. Now, a skeptic like me would say that big data is the vain hope that an arbitrary trawl through a haystack of data trash will uncover golden needles of information. Nevertheless, I will be the first to admit that there is enormous utility in some data analysis. However, many of the successes being claimed for big data are completely disingenuous. For example, the huge advances in genetic research are not based on big data, rather on the analysis of very, very large sets of small data. And the same can be said of claims made by companies like Google, Amazon and Uber. Now, by small data, I mean sets of focused, homogeneous and coherent data types, possibly vast in scale, but limited in variety and where the context is tightly controlled and well defined. Quite different from the context of big data. The tools for analyzing big data usually come with very fancy graphical interfaces, which of course means that the data has to be pre-processed to make it fit into a screen image. And please don't get me started on how generalized and ill-conceived diagrams can lead us all up the garden path. And it's not just the visualization of data. Much of the non-homogeneous noise in big data will be pre-processed away by human interaction, filtered out to leave us with large sets of small data for subsequent analysis. And as we have seen, even small data is haunted by paradoxes. It seems to me that big data isn't the solution to a problem, rather it is the acknowledgement that computer technology has created a bigger, impossible problem. In other words, computerization has generated masses of incoherent data, which we want to believe is valuable. However, we have little or no idea of how to extract that value. The outrageous claims being made for big data are just the latest example of the first step fallacy. They think they are reaching for the moon, but all they've done is climb the nearest tree. Only after the nonsense stops can an innovation, in this case data analysis, be used propitiously to its full but limited potential. Preposterous claims are made in the early days of every technology. X-rays were once considered a harmless novelty and used unguarded in shoe shops to check on foot size, and also to make photographic souvenirs for newlyweds. Bride and groom clasping skeletal hands showing their brand new wedding bands. In its pioneering days, electricity was claimed to have a therapeutic effect. Small electric shocks were thought to cure consumption, dysentery, cancer, blindness, worms, and impotence. Consider the Heidelberg belt. This is like a chastity belt with electrodes. Apparently, small electric shocks to the nether regions could increase sexual potency. Of course, we aren't that stupid. Oh no, I point at big data. Maybe President Pompidou was right. There are three roads to ruin: women, gambling, and technology. Women are the most pleasurable, gambling is the quickest, but technology is the most certain. So, will computer technology lead to ruin? Who knows? We may be damned if we do, but we're doubly damned if we don't. My advice is to follow the wisdom of Machiavelli. On his deathbed, a priest was delivering the last rites. Do you renounce the devil and all his works? to which Machiavelli replied, "This is no time to be making enemies." We have no choice other than to use computers. However, we must not be complacent about this diabolical technology. We must use it, yes, but only with the greatest of care and circumspection. Blindly handing over authority and responsibility to a computer system under the mantra of big data will really screw you up, along with all the surrounding human activity systems. So what exactly is my problem with big data? Now, in my earlier videos in this series, I questioned the notion of objectivity. And of course, this implies huge problems, even with the collection and analysis of small data. Let me start by deconstructing the notion of computer data. Man is a pattern-making animal. Computerization is the latest of our pattern-making schemas for imposing structure on our observations and subsequently making decisions, all with the intent of giving us a tenuous handle on our uncertain world. As I described in the second video in this series, our senses, possibly supported by intermediary devices like computers, do not input data from the real world in which we find ourselves. They capture delusions of that world. We use these delusions to imagine that world into existence so that we can negotiate our way around more or less successfully. Propping up these delusions is a dependence on category. We categorize without even thinking. Categorization is subliminal, the very essence of thinking. Category is not truth, but merely a cognitive fiction, what Nietzsche called refined ignorance. An act of choice, albeit a necessary one, that convinces us that we have explained our situation. Now, when it is a computer collecting data rather than our senses, as with big data systems, then there still needs to be categorization, only now it will be mostly pre-programmed. Either way, in using the subsequent data, we never explain anything. We merely describe, hopefully convincingly, to ourselves and to others. In observing, we divide the world up into discrete pieces, into data. We categorize. We separate each data object from everything else, so that we can model that data and thereby manage our place in the world. However, in categorizing each thing, whether directly or indirectly with computers, we restrict access to it. In observing, we introduce an asymmetry between the world as it is and as it is observed. In practice, the artificially separated parts, which are the basis of data, remain structurally coupled to each other and continue to operate and interrelate within the unobserved whole. Because of this asymmetry, all observation, and thus all data collection, is conditional. But these conditions are necessarily unobservable, unappreciable, uncertain, hidden in paradox, beyond observation, beyond cognition, beyond memory, and beyond logic, steeped in uncertainty. These asymmetries are necessary preconditions of observation, cognition, memory, and logic. The structural couplings, so casually truncated and discarded by data collection, stay on as uncertainties in the world. What I call data pollution is left to interfere with our actions in the most ominous ways. Examples galore to be found in the nonsense of healthcare targets in British hospitals. The culture of data-driven, rule-based hospital management has culminated in hundreds of deaths. Ambulances are parked in holding patterns outside overstretched accident and emergency units, just so they can keep to a government pledge that all patients will be treated within 4 hours of admission. The solution? Don't admit anyone. We even have the sinister pantomime of surgeons pushing dying patients out of the operating theatre into the corridor to keep death in surgery figures low. Post-operative deaths need less explanation for hospital administrators. What these examples show is that we must not think that the complexity of our world can be captured as a mere collection of objective data, so-called absolute facts. A fact is like a sack. It won't stand up until you put something into it. Everything is context sensitive. The differences between individual occurrences of data items in the external world and the ideals with which we choose to classify them shear off as a debris of detail, the aforementioned data pollution. We saw in a previous video in this series that we introduce structure into the world in order to turn uncertainty into risk. With such structures, we distinguish the world into categories. In doing so, we introduce yet more, and now far more subtle uncertainties, which lead on to the need to create future risks, as yet unknown and unstructured, and on ad infinitum. Such is the human condition. There is no escape. We are trapped because categories and data are our way of differentiating meaning. This cognitive sampling and categorization of things observed in the world are both the result of observation and the means whereby observation is possible. We don't observe categories, rather through categories. The very act of categorization remains an obscure selection process that is guided by the local success of, or otherwise, of previously chosen categories. Initially, our categories are aligned and don't cause us any trouble, which is how any descriptive pattern is perceived in the first place. But as time moves on, or the perspective or the environment changes, or systems get bigger, more generalized and more complex, that alignment will falter. Trapped in the world of our senses, our thought-created and thought-limited consciousness builds up an edifice of delusions from these distorted fragments. We project those delusions onto the real world and traverse that universal terrain of phenomena according to what we infer from our personalized sets of delusional data. However, the map is not the terrain, and so it is absurd to insist that a categorical representation of a thing is identical to the apparent thing in itself. What is observed is not the thing itself, but merely an internalized abstraction of that thing, a delusion of whatever that thing may be. This abstraction must fit into the categories constructed for it by observation, cognition, and delusion, thereby removing the observer from the existence of that thing and introducing a false objective reality. With category, we set out on an ever-expanding self-referential road from the natural but unknowable non-linear world in which we exist to the unnatural, objective, linear world of our perceptions. At each stage along this path, the utility being delivered overcomes all objections. Eventually, all absurdity is absorbed into the background of thought. Rather than nonsense, the absurdity is considered sensible, like zero or infinity, real absurdities. Subsequently, the absurd ideas are themselves used spontaneously in sense-making, rather than being recognized as something weird. In our book, Science's First Mistake, my good friend Dionysus and I use this interpretation to formulate our definition of human intelligence. Intelligence is the ability to deny absurdity. And indeed, intelligence uses that denial effectively to enable us to make our way in the world. However, the absurdity doesn't go away, and it can resurface as paradoxes to confound that intelligence. Just look at mathematics, where the absurd abstraction called infinity throws out numerous paradoxes like the Hilbert paradox and that of Banach-Tarski. Adding computers into the mix doesn't clarify our situation either. Rather, it amplifies the absurdity and creates a society in denial. Big data is not a solution. It is yet another symptom of this denial, an absurd belief in a generalizable algorithmic approach that can turn the ever-expanding chaotic assemblages of locally appropriate, specific, and highly subjective data sets, and yes, they are possibly useful. It turns those data sets into some unified model of objective, coherent, and valuable universal information. It's quite bizarre. Picasso understood that. Computers are useless. They only give you answers. More often than not, those answers are irrelevant, or just plain wrong, or they solve the wrong problems, or they create new problems, just like big data. Now, with this present data, I am asking you to recognize that because of computers, complexity has increased to a point where utility has turned into reliance. Reliance has become dependence, and the law of diminishing returns is precipitating a galloping descent into nightmare. Welcome to the twilight zone of big data. Thank you.